Hi, Harriet.
Hello, how are you?
I'm very good. It's good to have you today. Welcome to Huku Thinking Development Community Nairobi. We are so much delighted to have you today to speak to us. So we are really grateful for your time to coming to join us. It's in the afternoon here. So yeah. So without much ado, I think we can just get started. And you can just give a brief intro about yourself, and we can just get started directly to the topic of the day. So, welcome so much, Harriet, and we are pleased to have you today. Thank you.
Great. So I should start now, yes? Yep,
Yes, you can.
great.
You have the privilege to
Thank you
start.
so much. Okay, so firstly, yes, I'm very grateful to be invited to speak with you all today, and yeah, really interested in your community, what you're doing. I've been working a little bit with Nicholas, Michael, and Christopher, and we have really exciting project going on. So maybe one day we can update you guys on that. But for now, today, I'm going to be talking about Earth observation for inland waters. So I'll give a little insight into projects I've been working on and some tools that I think could be interesting or useful or exciting for people to use. And if there's any problems hearing me or anything like that, let me know. Um, Stop me. So Okay, so to start with, my name is Harriet Wilson. I'm a postdoctoral researcher. So I have a background in geography. I have a PhD in lake physics. So something a little bit different to what I'm talking about today. And what I'm talking about today, I've been working in for about 2 years now. So not a full expert, but I've been soaking up a lot of information, and I drew this little picture here of academia, international Earth observation providers, and users because I kind of sit in the middle of that. So I'm in academia, but I'm really interested in how people are using this data. And one of the projects I'll present on today was looking at how we can inform Earth observation providers to improve the Earth observation data they're making available to us all. But I sit in a room of kind of maybe more technical people, who you might really want to speak with them as well at some point, because I know you guys are all very technical, from what I've learned from Michael and Christopher and Nicholas. So yeah. Okay, I'm gonna talk about firstly Earth observation for inland water monitoring. Then I will talk a little bit about the Waterforce project, which is a 3-year project that I was involved in, and then some specific findings that we had within that project that might be relevant or interesting to you guys, so for Africa, but also looking at like local applications, and then some tools and some networks that I think would be cool if everyone was to get involved in. So to start with, remote sensing of inland water. So currently, why do we do it? Is currently like a very, very tiny percentage of water bodies are being monitored routinely. So in situ data is really lacking everywhere in the world, but definitely in certain places. And so Earth observation data has this sort of big opportunity to fill these gaps where there is no data available. And also, we're seeing like a much stronger demand from policymakers to have information about about water bodies, to understand trends and changes. So in Europe, we've got the Water Framework Directive, which is getting stricter and stricter, has more and more requirements, and we also see the United Nations Sustainable Development Goals very focused on water, and particularly Goal 6. Um, Currently, there's 5 years of Earth observation exploration. So there's a lot of research, but I'll talk a little bit about why it's challenging. And yeah, Earth observation is dynamic, so it's constantly changing. Some of the methods that were used 5 years ago are no longer relevant now. So it's a real interesting kind of area of science to be in. And actually, these data sets, Earth observation data sets in general, not just for water, they're some of the largest data sets in the world. So Copernicus is the second to largest data set of open access data following Google. So it's huge data, amounts of data. So real big data kind of analysis techniques needed. And yeah, it's a massive offering. A majority of it is free and open to all, so it should be beneficial to all. But we'll see in some future slides why that might not be happening yet. Okay, so Earth observation. Some of these slides I've borrowed from different people in my department who do courses on Earth observation, very, very detailed courses on the physics of Earth observation. So if you're interested in having someone speak about that, I think we could try to arrange something. But yeah, so Earth observation is the science of monitoring the Earth using remote sensors mounted on drones, aircrafts, or satellites. But it also includes this requirement of ground based measurements, which are necessary to support their interpretation. Most of what we're looking at is satellite based. But drones, yeah, and aircrafts are also really interesting in filling these gaps. So the types of sensors that we're looking at for water, for inland water, are optical sensors and radar sensors. So optical um, sensors capture, they are passive, which means that they read, they don't send energy, they just read reflectance from the Earth's surface or from the water surface, and they measure this reflected solar radiation in visible and infrared spectrum. And when you think about optical types of what can you measure with an optical sensor, you can kind of think about what you can see, so color, clarity, brightness, and then how these types, how that information relays into a water quality parameter, like what can you see, what types of water quality parameters can you actually see with your eyes. um but of course it's not just visible, but that helps you to understand, capture that. And then radar sensors can be both passive or active. So active sensors actually emit microwave signals and then they record the return. So a different approach, and they are more about looking at object size, shape, surface roughness, and water content. So a lot of quality water quality products come from optical sensors, and
Excuse,
uh,
excuse Harriet.
yes.
There is, a, there is somebody saying that the slides are not moving. Probably you can put into this presentation more.
Ah, thank you. So it's because it looks like, is it moving for other people
I don't know.
or
Because
for nobody?
all that time they were in slide one.
What did you say? Sorry.
We were seeing only slide one. Slide number one.
Ah, okay, okay.
Yeah.
Let me see what I can do then. And you don't see that. Do you see that change? No.
Yes.
So you see which slide do you see? My background.
At the first slide.
Just the first slide.
Yes.
Hmm. Let me see how to share this without. Okay, entire screen maybe. Okay, you see that now?
Yes,
The
and now this
second,
is,
you can see the second screen now.
yes, yes.
Okay, great. So this was my background, and that's just what I've said. This is the outline of what I'm going to talk about. This I will make my slides available to you all, but this is just my summary, which I've said about why we're really interested in Earth observation from space. This little image is measuring chlorophyll for a lake in China. Um, so then here we've been talking about optical and radar sensors, which is what we use to measure water quality and water quantity. And here is just a kind of chronology of some of the satellite sensors which have free data, which we use to measure water color in particular, so water quality parameters. So yeah, of particular note, a lot of people use Sentinel-2, which is European satellite. So that's of particular note. Okay, so when you're looking at if you're just looking at water and you're kind of trying to imagine what type of variables can we measure, something which my supervisor always says to me is, when I'm just in the field, can I see color changes? So like blue to green to red, different kinds of color? Can I see clarity changes? So some water bodies are very clear and some are turbid. And can I see changes in brightness? And those are all clues for quantifying absorption and scattering. So those are the types what can be picked up by satellites for water quality remote sensing. But there are a lot of challenges, very specific challenges to remote sensing of inland water. And this has actually, if you can see in that the second image below, um, is actually why, compared to other types of remote sensing, so remote sensing of forests, for example, inland water has been kind of slower to take off. And a lot of the published papers are very focused on algorithms, on atmospheric corrections, and less on applying the products. So there's huge amount of research that went into the kind of R&D, the research and development stage. And the reason is because there are some complexities, inherent challenges of remote sensing for inland waters. And so firstly, an obvious one is that most water bodies on Earth are smaller than the available satellite data resolution. So the vast majority of water bodies on Earth are small. So that kind of limits the use on small water bodies, but also far more optically complex than oceans. So inland water is biogeochemically complex and optically complex, which makes it very difficult. One pixel, if the pixel is very large, may actually incorporate a lot of changes in the biogeochemical conditions or the water quality conditions. So we really need both of those kind of points demonstrate the need for really high resolution, spatial high resolution. The other point is that sometimes, surface water is not really representative of the whole water body. So you really see, like in lakes with deep chlorophyll maximums and stuff like that, you can't really capture that from just measuring surface water. And then this is probably the big one, is that the atmosphere contributes to 80 to 90% of the total top of the atmosphere signal at the blue-green wavelengths. So the kind of signal we're trying to capture or understand from water, which is the blue-green wavelengths, is also the same wavelengths that are heavily interfered with by atmosphere. So essentially, atmospheric correction is hugely important, and changes in the atmospheric correction can just massively change your results. So there's a very strong sensitivity to those corrections. And yeah, so and then other issues are land, influence from land or shadow from land, and also water bodies. The bottom of the water body for shallow water bodies can make it further challenging. So you have to make a lot of corrections, and that can kind of lead to very high uncertainty for remote sensing of inland water. So what types of information are available today? So obviously it's constantly evolving, but we do have sort of products that are currently available and operationally available, meaning that they're not just in research, that large global satellite providers like Copernicus are providing them, which means that they've gone through like rigorous validation, etc. So we've got lake water level, lake water extent products. We also have, oh, that's supposed to say river water level. So we have river water level products. But again, these are all like large rivers, large lakes. Then you also have surface water temperature. So this is coming from thermal sensors. You've got lake water leaving reflectance. So as I said, this then leads into these water quality products. So you've got chlorophyll A, turbidity, trophic state, CDOM, and these are the occurrence of cyanobacterial blooms. Again, these are kind of limited to larger lakes, and these products don't exist at the moment for rivers, but we can talk about that more after. Yeah, and then you've also got groundwater products, not which are kind of in development more. Okay, this is the kind of processing steps involved. Again, this is really not my expertise, but I do work in a room with the guys who are responsible for some of those products. So you've got data acquisition, so downloading the images. To do this, you can use Copernicus Data Space Ecosystem, or you can use Google Earth Engine, as you guys are probably well aware. Then you've got data pre-processing. So this is where you resample, you reproject, and you also do cloud detection. So being an optical, this is for optical sensors. They don't see through clouds, so all of that data needs to be removed and flagged. And then you've got atmospheric corrections. So again, the atmospheric correction of inland waters is very sensitive because you're trying to get the blue-green bands. And so atmospheric correction has been really a big topic in literature for inland waters. And then you get the relevant bands, and then you can use algorithms which have also, sometimes they use blended algorithms, a number of different algorithms or an ensemble of algorithms to estimate the water quality indices of interest. So chlorophyll A, or total suspended solids, or total suspended matter, and other different types of variables. So for a lot of this, you can also use SNAP, which I'll show you is a European Space Agency's software. And then you can do batch processing, so you can sort of run this for many, many images using Python. And yeah, my colleagues run some training on this kind of thing if you're interested. So atmospheric correction for inland water, as you can see, is really, really important. So this has come from my colleague Darlene. And before atmospheric correction, you have this kind of spectral signature, which is dramatically changed after atmospheric correction. So there's this huge importance of it for inland water. And actually, there's a lot of kind of tools available for atmospheric correction, and often they are using multiple different approaches and kind of blending them. So I can show you here, this is processing chains for some operational products. So on the top, you've got lake water quality products. And you can see here multiple, so satellite images go in, there's the pre-processing going on. Then you've got in the gray, you have um, different algorithms being applied, and then you come have the different water quality parameters, and then they're aggregated to 10 days. So that's an example of a kind of operational processing chain. And these products are available within the Copernicus Global Land Surface Service. So both of those are available there. And this similarly shows the processing chain for temperature products. So now that kind of background is out there, I'll just talk a little bit about the Waterforce project. So the Waterforce project was a 3-year project funded by Horizon 2020. And the whole purpose of the project was defining the future of inland water services for Copernicus. So it's a scientific partnership of over 20 different partners, and the whole idea, it was a coordination action, so collecting information from users, making assessments of how different users are currently using Copernicus data for inland water services and how they could potentially be using them. And this was delivered then to Copernicus, and will be some of the actions and recommendations will be used to improve their service in the future and determine where investments are made, etc. So we had 6 different working packages. So you can see here, there's the policy, stakeholder, and service analysis. That was kind of the starting place to collect like who's using, who are the stakeholders of this type of information, this type of data. And then we had different work packages for water quality, water quantity, aligning in situ and satellite activities, being because Earth observation data is heavily reliant on the availability of in situ data to create meaningful results from Earth observation data. And then there was modeling and data assimilation work package. And then all of this fed into work package 6, which is a roadmap. So this was the roadmap that we delivered to Copernicus. We also delivered to other European agencies, and we also presented to the European Space Agency. So kind of informing all these different groups and actors of what we had found from user communities, what kind of recommendations we had for improving their impact on the water sector. And this was my main role, was working in work package 6. So the Waterforce roadmap is a very long document, but if you are interested, all of the documents are available on the Waterforce website. So it's just down the bottom there, www.waterforce.eu. And there's also a leaflet that summarizes it. I would say if you're not super familiar with the kind of infrastructure of the Copernicus program, it might not be so interesting to you, but there are elements that I'm going to talk about today that I think are really interesting from a user perspective. So the Copernicus program is the European Earth Observation Program, and it's otherwise known as the Eyes on Europe. So it's kind of complex structure. It is publicly funded, and you have the Copernicus services, which include land monitoring, emergency management, atmosphere monitoring, marine environment monitoring, and climate change and security. And a lot of water products kind of exist across these different services, which can be a bit complex and complicated to find. But most of them lie in the land monitoring, in climate change, and in emergency management. But yeah, you've also got kind of the space component, which is where you've got the satellite missions, so Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-4, etc., and next generation Sentinels are being developed there. So yeah, you've also got this user forums. So this is supposed to really be a user-driven program. So there's definitely scope always to understand who's using the data, what people need, what kind of social, economic, environmental benefits can be had from new missions or from new services that can be provided. So some of the kind of core benefits to having water-based products and services being provided are that, for example, member states, so this is more European focus, but member states can have the data that they need to report on their water bodies for agriculture and also for climate adaptation policy. So making sure that the data is provided couples well with the policy requirements, or developing policy, can inform the European Union on problems, environmental issues that can then feed back to policy. Yeah, but there's also, and that's the same with SDGs, Sustainable Development Goals. But there's also some other really, really interesting impacts. The emergency services can be really reliant on these products, which could provide more confident forecasting of extreme events, can improve preparedness, so preparation for extreme events, and resource allocation is massive. So that's usually on a kind of national, regional level government focus. But there's also a lot of private, public health services, similarly, another public good that can come from this data. A lot of private benefits can also be had for companies or for communities. For example, agricultural companies could use Earth observation products for irrigation planning, for food security forecasting, and for reducing pollution, reducing losses, ultimately as well, increasing profits can be also used. Yeah, and water treatment, can be really facilitate water treatment companies and utilities in the future. So some of these applications are currently happening, but many of them are not. And we're really interested in how to advance the use of this Earth observation data for these applications. So this is just a summary of the consortium, which was 20 plus different organizations, the different work packages, and how they work together to all of them feed into this final roadmap. So recommendations were taken from all working packages and fed into the final working package, which included everyone. So everyone was involved in the final work package for the roadmap. And yeah, overall, we engaged with 800 people outside of the consortium. So that was through webinars, through surveys, through interviews. So a massive user engagement. So they were all people within the water industry or relevant sectors who were either benefiting from this information now or could be in the future. So water quantity, what we found was that there are a lot of products currently available within Copernicus. So these are products that are operational, they're already ready. Anyone can download them and work with them. So any of you could download these products. And there are kind of a lot of them. So for water quantity, there are 800. But as you can see, they're quite varied. So soil moisture products, land cover products, precipitation products. And, sometimes they come with varying degree of kind of user information. Sometimes it's really complicated to figure out what they are or how to use them, which is a big feedback we received. And there's also lots of lacking products. So groundwater products were lacking. groundwater being hugely important in many countries, the main source of drinking water. Bathymetry information, higher resolution products for soil moisture, for other variables. Sometimes the resolution is um, too coarse, and evapotranspiration also super important. So they're all really the products that are kind of identified as being lacking. And then we've got water quality products. So we found by comparison 800 water quantity products, there's actually only 9 operationally available um, water quality products. And it's also very important to note that these products are only available for large lakes. So there are 117 million lakes in the world, and we have operational products for just 4,000 of them. So obviously, um, there's a big lack there, but in terms of variables, but also in terms of coverage. But still, there's a lot that can be done with that information. And also, river water quality is currently lacking, so there's no operational products for river water quality. Um, Theoretically, the spatial resolution um, is okay, is theoretically allowing for that kind of product, for wide river products to be processed, but this has not been translated yet into operational products. So it's kind of lacking. There are complexities with rivers versus lakes, with the surface roughness, with the movement of water and everything like that. So they're not operationally available yet, but hopefully that would be something that would be developed. If you're interested in looking at like a whole range of parameters, so there are many tables in the roadmap, and I've given you the page. So from page 38 onwards and tables 5 to 9 is a list of all different types of parameters, and then a kind of assessment of how mature the science is. So for many of these parameters, there is no operational product, which means that there's not a global satellite provider giving that product with a level of certainty for global or for a regional area. But there might be a number of studies, a number of small academic studies that are looking into that, or a few um, academic groups that have particularly focused on that. But for many of them, there is a lack of in situ data sets to develop those. So that really came out heavily in the analysis, as there's this big lack of in situ data to really develop those products properly. So commercial opportunities. So there's these 2 other reports that might be interesting to you. One, and they were authored by myself. So one is on capacity building and how can these products be more widely understood, be more widely used by the types of groups who could really benefit from them. And then the other one is on commercialization. So how can people be taking this free and accessible data and using it to create business? Um, and I think this is really interesting because there are huge opportunities for making money from Earth observation data, and we see it a lot. There's a whole sector that's growing all around the world, and I'll show you a bit about where it's growing the most. But this is the downstream Earth observation sector. That's how we call it. And there's a lot of potential future opportunities. So agriculture is really key because water plays a massive factor in agriculture. And particularly as satellites are getting smaller resolution, there's a real opportunity in irrigation and precision irrigation, and particularly as water is, and food security is becoming an issue because, um, there's a lot of water scarcity in different places. That is a real growth area. Drinking water and utilities is kind of a big potential customer, but it's mainly public sector, and it's not necessarily going to be a good it wouldn't necessarily be a good customer. Well, it depends. But CDOM in particular is something which costs drinking water companies a lot of money. So monitoring CDOM, color dissolved organic matter, is another area that's really financially viable. You've got energy sector is really tough to change, and that might come more from internally. Environmental monitoring is a big sector and a big opportunity for smaller companies and smaller businesses. So that might be like using drones and satellite data to monitor an area, or many things can go into environmental monitoring. But yeah, and then another massive growth area, which again might be a difficult customer, but is definitely moving towards Earth observation data, is the insurance sector and natural hazards. So looking at how many areas that have been flooded and stuff like that. So that's the predicted to be the biggest economic growth sector for Earth observation data. And it's also worth noting that in surveys, ERSC is a community of companies, Earth observation companies within Europe, and they do an annual survey. Oh, hello. They do an annual survey, and they find every year basically that there's a real lack of skilled personnel. So there's also should be a big opportunity for skills. If you have these Earth observation skills, which I know many of you here do, there should be also growing opportunities to have to your skills will be in big demand from companies. And this is Europe based, but 75% of the companies find it difficult to find and hire staff with the skills that they need. And also, they accredit this to a lack of Earth observation training in many countries. And yeah, so what they really struggle with is programming and development skills. Um, at the top is the top difficult to hire. So that's an interesting result. There are lots of gaps in Africa that we found within the water force assessment, and it was actually really noted by our assessor. So within the 3-year project, you have to go back to your funder, who was Horizon 2020, which is under the EU, so it's EU money. You have to go back to your agency and show them what you've done, that you're on track, and then they give you feedback and ask you, okay, can you go more into this or that? And something they were really interested in was applications in Africa and users in Africa, which we didn't necessarily engage with enough. But from what we did learn and our own assessment, we found that there are some products available for Africa. So, for example, the 100-meter lake water quality products are available in Europe and Africa. So that includes a lot of lakes within that region. But there's generally a real lack of in situ data for developing products and for validating products. And that's not just water quality, it also includes things like soil moisture and stuff, real lack of that in situ data. There's also a shortage of applications based on African water bodies. So you can see that from this study here. Looking at publications from around the world on using Earth observation data for inland. So these are like gaps which can be filled, which are, opportunities in a way. And also there was a limited penetration of Earth observation technology for water at the local scale by local communities like you guys, and also for private sector. So that's kind of general. As you can see here, this is kind of classic, like this is the Lake CCI products, which are really awesome, and I definitely recommend using them. But you can see that they might be validated on 79 lakes, and maybe only a very small handful of those are in Africa. And then they're applied so the algorithms and the processing chain is validated using these small number of lakes and then applied on many lakes, including quite a few in Africa. Um, so there's that real lack of in situ data from Africa. But even without that, you can still get, it can still be representative. So the validation can still be representative, and efforts are really made to make the validation as representative as possible. And these are two freely accessible open access databases, and they're the top. These are the databases in which these operational products use. So they really are kind of the state of the art databases, and they're both open access. And they include in situ data, all the in situ data that's been collected for validating these products. So Gloria is one, and Limnadis is another database that was developed by my university. It's also open access. And you can see that, they try to have a full representation of chlorophyll A, of lakes with differing quantities of chlorophyll A, of differing transparency. They also use an approach which my supervisor, Vagelis Spirakos, developed, called optical water types. So they ensure that that the validation includes all of the water types, even if it's not geographically representative. The goal is at least to be optically representative. So you can also see here that you've got, this is the number of active users for Open Hub. So it kind of gives a little indication of how many people are using Earth observation data. This is not specific for water applications, because they don't usually segment water as a separate kind of user type, which we're trying to encourage, but that as a result of Waterforce. But this was not done in this report. And as you can see, Africa and Oceania are really much lower users, and North America is relatively low, but they also often are using NASA offerings. So NASA is another big global provider in the States. So there's there is definitely an increase, a desired increase of users in Africa and Oceania. And also, I think this is really important, and what I was talking about before is about who is benefiting, then the commercial benefits of Earth observation data. Again, this is really general and it's not specific to water, but it's just looking at the amount of revenue that is enabled by Copernicus and their Earth observation offering. And Africa and the Middle East, which is obviously a big region to lump together, but they're only taking 5% of the global revenues, and that's projected to increase to 6.4%. But of course, there really should be taking a bigger portion of this global revenue that is being provided by this free and accessible data. So these data sets are open access, free and accessible, but there are limitations as to why they might not be taking as much global revenue from this. So this was a survey I did with 336 respondents, and hopefully maybe some of you were in the survey, I'm not sure. But everybody who was included in the survey was from the water sector. Using the same classification, we put Africa and Middle East together, but I think I have to separate them because we didn't have actually any people from the Middle East. It was just Africa. So, but we had a lot of researchers, a mixture of academia and public sector. So that's the demographics of the respondents. But what's interesting is that we found that there really are the kind of barriers that are preventing people from using Earth observation data is often a lack of skilled personnel again. So that's interesting because I know like a lot of you guys have these very sought after skills. A lack of good validation data, which, as I've just shown, is a real problem. There is a lack of in situ data for validating these products. And also this cost of data, which is interesting because a lot of the data is actually free. But it may be the case that people are not aware of the data, or people are looking for higher resolution data that is not free. So there's, things like Planet, which is the new satellite provider doing very high resolution data, which is not always free. There's these there's this mismatch between what's being made available. So GIS is kind of training that has been made available in many places, but is no longer in our survey. People said they didn't really need GIS. What they actually need is right down the bottom. So if you look down the bottom, these are the skills which are most in demand. So machine learning, AI, deep learning, big data analytics. So these are the kind of skills where there's the biggest gap between activities that people have received in the last few years and activities that they need. That's where the biggest gap lies. And I think that's really interesting that that's where you guys are working. So then now just to switch just to the end of end of my presentation, looking at upcoming projects and opportunities. So there's this project Dunia, which is ESA funded project, and they have free cloud processing space, which I recommend everyone signs up because it's very expensive, and they're offering this for free for the first people who sign up. So I'll show on another slide their website and some bit more information. There's another project called Sarau where they're building data centers, but I'm not sure. They're building data centers around Africa, specifically for the purpose of Earth observation data exploitation. I think that will start, um, or maybe perhaps it started. I'm not sure. These are not these are not projects I'm associated with, but I think they're really interesting. There's the DARA project, which actually my colleague here is heavily involved in, and that will commence shortly, but that's a massive project looking at increasing Earth observation education in Africa. So getting more people trained so that it can become more part of university curriculum, and then maybe more startups will occur, and more opportunities there. And then there's the African Lakes Remote Sensing Network, which is a community which probably should be on the network section below. It's a community. I'm not involved in that myself, but I know people who are, and there'll be a presentation on this at some point this year in the World Water in the work stream that I'm part of, and that Nicholas, Michael, and Christopher are also part of. So we'll have someone speak on that. Maybe you can find out more information on LinkedIn or something. Yes, there's networks. I definitely recommend people join these networks. So is Geo is a really big, important organization for Earth observation, and AquaWatch is a branch of Geo which is focused on water quality monitoring. And we have an early careers society, which I am a co-chair of. So we definitely recommend that people get involved in that. Also, I'm facilitating the World Water Quality Alliance Earth Observation Workstream, which is convened by the United Nations Environment Programme. We have monthly meetings, and we'd love for everyone to join that. There's another group which you might be aware of, which I'm not involved in, but I think maybe be interesting to you, which is Geo AI Africa. And I know they have a LinkedIn, so perhaps you'd be interested in linking up there. Then there's like a bunch of training materials for anyone who wants to learn more about exploitation of Earth observation for water quality monitoring in particular. So those links are all available. There's not necessarily, there should be more training materials, maybe, but there's also a lot available and around. So Snap, I don't know if you use Snap, but I do recommend maybe looking into it because people don't generally use Google Earth Engine for water quality because of the need for atmospheric correction, etc. So yeah, Snap is definitely a tool to look into. Um, it's free, completely freely available, and you can also run it through Python, um, as I showed on my earlier slides. So yeah, it's worth exploring. Then you've got Lake CCI products, which I mentioned. So these are very long-term products, so 1992 to 2020, and they have sort of state-of-the-art algorithms for water quality parameters like chlorophyll A. Um, they also include lake surface water temperature, and you can download like just a lake, one lake from here, and then use it in Snap if you want to get a feel for it to start with. And then there's NOAA Coastal Watch Portal, which is kind of a American offering. I don't know so much about it, but I think it looks really interesting, and I think it's definitely well validated. So there'll probably be a lot of documentation about how the products are developed. This is the sandbox that I was talking about. So it's an all-in-one, easy-to-use platform. So it can even work on your mobile. So it really majorly reduces the kind of computational power you need, and it allows you to run Jupyter notebooks and do quite complex analysis. So if you sign up to this now, you get a kind of allowance, and I definitely recommend it because I've had a little play with it. So yeah, I think it's a good way to learn. And that's it. Thank you, everyone.
Okay, so thank you very much. Thank you very much, Harriet. This was really a good session, especially showing us the opportunities that are there in regards to the hard observation. That was really nice. So at this moment, I will welcome questions from the members and any comment if you do have. And I can see a lot of questions. People have already started raising their hands. This is interesting. So who should you go first? Kevin. Kevin, yes, Kevin. You can just open your mic, introduce yourself a bit, then you can go on with your question, please. Yes, Kevin.
Okay, thank you very much. That was a good presentation, Harriet. Thank you. And also thank you, GDevs Nairobi. Well, my name is Kevin, as you have seen. I wanted to ask Harriet, maybe do you have internship or activities, maybe learning activities where we can take maybe, while learning, you also do some of these things, physically or hands-on to gain more experience. Do you have such activities in Africa, especially sub-Saharan Africa, or Nairobi to be precise? Thank you.
Yeah, it's a good question. I think there are opportunities around. Do you mean like an internship, sort of like online training, or there is one link I can provide. It was on my screen, but I kind of ran past it. Is the there's one university that has linked up. So the World Water Quality Alliance that I have run a work stream within. That's a voluntary group, so anybody is welcome to join that at any time. And we have really experts there. We have who run big projects. We have volunteers there, so we have kind of really different community, and through engagement in there, you may become aware of different opportunities. And Geo Aquawatch also have a real focus on opportunities and like sharing opportunities that are available. So I recommend joining those two networks. But I'll give this link as well to there's a master's class, and I know it's focused on water development. So water monitoring, really. It may be a little bit more in situ focused, but we have in the past put an earth observation module into the course. But what's good about that course is it's a course that I know is subsidized completely for people who meet requirements. So that's like a good opportunity for a master's course. But yeah, I have a list of resources. I'll try put in the chat as well for training materials. Some of them are not live. That's the problem. Some of them you're just on your own doing them, but some can be live.
All right, thank you.
I'll just add. Yes, where should I share my presentation? Glass. Oh,
Okay. Yes, yes. I think Nick is, I think,
frozen.
is we lost. Yeah, but you can actually, Harriet. First of all, thank you for the nice presentation. Um, it was really insightful. So you can actually share it here. Then we will be able to share it in our communication channels.
Great. I don't know, is it possible to share on this? Just to dump let me try.
Okay.
Oh no. Okay.
Um,
Maybe through email or in the WhatsApp
yeah.
group.
So what you can do actually, you can share to one of our email,
Yeah.
either Nick, Chris, or me or Christopher, and then we'll be able to share it in the community. Also, for those members maybe who are here and then they are not in subscribed to our community email group, then they can do that so that they can get all the materials that we train. Yeah, I hope that will be clear. Okay.
Great.
Yeah. Uh, yes, yes, yes. Any other question, maybe? Okay, I can see. Let me check. Yes, the baby. I can see you have a question. Please. Okay, okay. Okay. We'll be able to share it. Let me just get it right away. Maybe any other question? I can see Yazin has raised a hand. Maybe you can just open up the mic and jump in. Yes, Yasin.
Hello.
Yes.
Yes.
Hello.
First of all, thank you very much, Doctor. The presentation was really informative. So I am also doing master from China, and my work is also related to water. So your work was mostly related to me. So I want to find the same research area or research gap in my country, Pakistan. So I also want to learn the techniques which you have already applied. So more things I get your from your presentation. So I want to learn some techniques. If you have any learning techniques link or any helpful material, kindly share with us. Thank you so much.
Great. Yeah. I think so you mean to I think there's a lot of it depends. So you are working in water
Yes, yes.
in Earth observation, or you have different methods. I think
Yeah, yeah, Earth observation. I already worked on the wetland
okay.
changes, historically wetland changes. So it is also related to water. So I also extend to my field as I do more publications. That's why I want to learn the techniques you have already applied.
Yeah, definitely. Well, my colleague, he is not here today on Saturday, but they work a lot in wetlands and using SAR sensors to look at changes in the water table in wetlands, which I
Yes,
think
yes,
is like a very emerging area of Earth observation, and it's like still in its research development stages. But I can provide some links to papers. Um, and I think the same, if you look at the same resources I showed for Africa, um, about you can see some on some of those user reports there are global maps which maybe you can see that there are probably big gaps for Pakistan as well, I imagine, or you could look at in situ data
yes,
availability in Pakistan and see if that is or which water types, optical water types, are most prevalent and whether they coincide with other studies. Yeah, I mean, I would say it's important to note I'm not expert on everything, but I'm gathering links to people
yeah, yeah.
who are doing these things, and I think that's a really good way to do it is to kind of start to find other people who are studying what you are studying, even if it's like in different labs, um, even if it's they are applying it to different places, you can still learn a lot on the methods.
Yes, yes. Thank you so much, Doctor. I will be thankful to you if you can share the email or contact of your colleague who already worked on the wetland. So if you want, then you can share.
Yeah, for sure. I will share the paper, which I will try to find the paper just in 1 minute but
Yes.
thank you.
Thank
Thanks for
you.
the
Yeah.
Thank you for
question.
your precious time.
Okay, okay. Maybe I can also add something on the same. So Yasin, actually, um, there is, for example, okay, currently I'm working on RCMRD, and they have done quite a lot on wetlands mapping and analysis. So maybe you can I'm going to share a link so that you go there on the website and check if you can be able to find some useful materials on the same. Yeah, because they have done a lot on it.
Yes, thank you so much. Thank you so much.
Oh yes, Nick. Um, we were trying to look into the questions. I don't if any other question maybe um, to Harriet. Joseph, do you have any question?
Hello. Thank you for the next presentation, Harriet. And I have one question for you regarding the availability of the in situ data. And you find that in Africa, like we have a larger gap when it comes to the in situ data for the lakes. Is it due to the high cost of acquiring the in situ data, or what might be the problem of having the in situ data? And maybe what are some of the methods which you can come up maybe with in order to have the in situ data for validation purposes? Thank you.
I think this is a really good question, and it's challenging. I think that, yeah, I think part of it must be. I mean, maybe people on this call might know more than me, but well, in one of the groups that I'm working, we are working with the technical specialist for SDG Sustainable Development Goal 6.3.2, which is all about measuring the proportion of bodies of water with good ambient water quality. Oh, there's a bit of an echo. Maybe someone is. So from what I've heard from their data collection campaigns, so they gather data from everyone from all the countries, and try to put it together to produce global monitoring effort, right? And I think what's challenging is that it's a lot of sometimes it's about money. I think in situ data collection costs a lot of money. Sometimes it might be about instability of organizations. For example, an organization might be collecting data and then they might change, the government might change, or their goals might change, and then their data collection their goals might change, and they may stop collecting for a few years and then they might start collecting again. So I think that can be a big factor, sort of instability in organizations responsible for that. Maybe in some transboundary water bodies there can be political reasons, particularly like not to collect data. So it's kind of complicated. I think it's a really big challenge. Having data is important because it allows you to sort of know how things are changing. It's a really important step in achieving better water quality, is knowing what the situation is. But at the same time, sometimes it can be a rather dismal picture, you know? You might just see that the more you know, the more you see. So it's, I don't know the answer. Do you have any ideas on that? Because that's a very good question.
Hello, I think what you have said is just right. Another thing that has contributed to lack or insufficient in situ data in Africa is probably skills or the right skill acquisition. And probably this is why Copernicus can come in and try to push some of these skills because Africa really has the potential. And the only problem is acquiring the skills and the resources also required to gain these skills, which can also go a long way. So yeah, there's a lot of data, there's a lot of opportunities, but the skills are also a challenge, in my opinion, though. Thank you.
Thank you. Yeah.
So I can see Jakalia. Maybe you can just jump in. Can see you raised your hand. That's Sonda. Yes. It's hard. The name is hard to read. Yes. Sonda Jakale. Maybe you can jump in. Yes. Okay. Yes, Mercy. Please jump in and ask a question. Hello, Mercy. Are we together? I have seen you've raised your hand. Or any other person who is ready with a question? Okay. Yeah, so I think, yes, Mercy.
Yeah, sorry, I was having a problem with my screen. I was
Okay.
trying to unmute myself. Yeah, just maybe to agree with Harriet, I think the main challenge with the lack of data in the in situ area is mostly because of cost. You know, doing studies in water quality is very expensive. Maybe I can share an experience as I did my master's. My thesis was in water quality in springs and river water. And the main challenge was actually cost and even access to the laboratories where you do the other parameter testing that you cannot do in situ. So I would agree the main challenge is that cost and also lack of expertise. Thank you very much.
Yes.
Thank you, Messi.
Yeah,
I do
so
hope like maybe I think, you know, if this data is beneficial for everybody and also Europe has an interest in that, I do think it's, you know, you can use this kind of information you can use in proposals to demonstrate the importance of what you're doing, which maybe you already know, but it's a good way to to maybe receive funding from other places because it's really important. So the cost shouldn't just be on, you know, shouldn't if should be, you can push that back. You know, the European Union and other funders really should take some responsibility as well to initiate some changes. So it's good to remember for for proposal writing.
yes. So thank you so much. Any other question? Feel free. If you have any question, you can just open your mic or you can post them on the chat so that we can be able to see it, or even a comment. Yeah, it's accepted. Yes. Yes, Nick. Back to you. Maybe if you have anything to say.
I would just say one thing I've just added for, I think Yassine, you mentioned interest in looking at gaps for Pakistan and for other places. One of the reports I looked at is the Copernicus user report, and that's quite interesting for looking at how it gives a global idea of where data is being used. And you can also look at the Copernicus market report, which was also from use, but they look at how much money is being created through this data, and it also has global idea. Also shows different sectors, so you can see where different opportunities are as well if you are looking from a private sector point of view.
Thank you, doctor. I will see to the link. I will see the description. Thank you.
So, okay, so thank you very much, Harriet, and we do appreciate the presentation. Something I would also want to add is about the regularization or the government policies regarding in situ data collection, because at times you might find that there are challenges when trying to get this data with regard to the government regulations and the procedures that one has to follow. I think this is something to do with the policy, and there is something which needs to be done so as to ease the process and ensure that most of the persons who are interested in this programs like the data collection, the in situ, and also the development of the data also, especially for the in situ data. This could really enhance that process, and it could very enrich the opportunities that we have, just as we have explored and showed to us. It has been really great to even understand, even beyond the water quality, the other opportunities that are surrounding our observations. So this was really a nice opportunity for us to learn a lot, and we appreciate your time with us and your kind acceptance to come and speak to us. It was really nice. We really appreciate that. And as you can see, from the members are really fun. Yeah. We learn much from you, your expertise, and really we are grateful for that. So for us, we appreciate very much, and as Google Teaching Developer Community Nairobi, we are an open source community. So for us, we are open source. So everything that we use open source data, we use open source tools, we use even if the people themselves are open source. So we are really much grateful, and I see. Thank you for sharing with us. So today's presentation is here shared with us. You can access the link. So thank you so much, Harriet. We are really grateful. So without much ado, I would like to call the meeting to end if there is no any other question. So, but you have not lost anyone out. If you have any comment, you have anything to ask, you can just ask now. We have our Google group. I've shared the link. You can just write to us through that, or check in the email. You can just write anything you want. You can be free to reach out to us, and we'll be glad to help you. So, and even for our members, if you have any presentation or any project that you are willing or want to share with us, we are open for that. You can also share with that. You can also express your interest through the email or the good country would be really great to have you present as one of the guests. It's really good. So thank you so much, Harriet. You are much welcome another time, and we appreciate you very much. Thank you.
Thank you very much for inviting me, Nicholas, and thank you all for listening.
Thank you so much. So, if no other thing, we can end the
I have just added a link to my presentation in Google Docs there. I hope hopefully it works, but
Yeah, this one is working nicely, so I think it's accessible to everybody. So you can just count. Or Michael, you can say something before it goes.
Not really, not really. Mine is actually just an appreciation for Harriet for the nice presentation. It's really inspiring with what you're doing in water, and we're also very interested in water quality and stuff, and we really appreciate it. Thank you.
no, it's great. I hope we can, we'll continue to collaborate, and I'm very interested in what you guys are doing. So I really hope Earth observation should really be a tool that is being widely used and is benefiting people. So I like to see that happening. So
Yeah, sure, sure.
So probably next time we'll work on a project in Nairobi. Yeah.
great.
Okay, so thank you very much, everyone. We can end the meeting.
Take care, everyone.
So goodbye.